So I'm Steve, and I like networks. How many people here hate networks? Hooray! So you're in the correct room. What I want to talk about today is monitoring the things that you don't own. And what I kind of mean by that is, to a very large extent, you can pretty easily monitor the things that you do have control over. And like, okay, I'm standing here in a monitoring conference, and he's saying that, oh no, it's really easy to actually monitor stuff. It's easy to collect the data. I realize it's difficult to like cut that up along particular dimensions to get something useful out of it. But the main point is that you actually probably have access to a lot of stuff. You can instrument stuff, you can collect that data, and you can action stuff from that data. The hard part is that once you actually build a service and put it out into the wild, you lose a lot of control over it, right? Like once you put something out into other people's networks where you have users and other people's networks that they have to traverse to get to your stuff, things get alarmingly complex very quickly. And one of the problems is that there are just so many networks and so many individual networks that individual operators are managing individually, and it's somewhat alarming that it kind of works. So, once you've got any kind of non-trivial service that you're building up, you're probably going to have some kind of combination of your own data centers that are located in geographically separate locations. You may be co-located in somebody else's data centers because that's a lot cheaper. You might be planting VMs inside VPSs. You might be planting containers in cloud providers or building out higher level cloud services. And for a lot of your stuff, you're quite likely going to be putting a CDN in front of it so that you can actually get closer to your users. And this creates a really uneven surface that's very difficult to try and debug when you've got thousands of users out there in the wild accessing your weird homegrown setup that's grown organically over the years, because of course it's grown organically over the years. And the minute you're trying to balance all of this stuff, you're going to have some kind of DNS load balancing or IP anycast, which introduces a ton of unpredictability into where users are actually going to go. And suddenly you have all of these plates spinning, and it's really difficult to keep everything up, and it's really difficult to keep an eye on all of these different services that you're watching. It can be very difficult to pinpoint what you expect to be happening versus what's actually happening in the wild. And like one of the most obvious things is that the minute you start doing any kind of IP anycast, traffic doesn't necessarily go the way that you expect it to. If, in this example, you have a set of North American users and you have an edge in New York, and you have a bunch of European users and you have an edge here in Amsterdam, you would kind of expect, or you would kind of desire, that all of your European users hit the Amsterdam edge, and all of your North American users hit the New York edge. But in reality, it's not going to shake out that way. You might, and I'm pulling numbers out of the air for the purposes of this diagram, you might get 75% going to the correct place, and you might get a ton of traffic going across the Atlantic. This stuff is finicky, and it's tough to get right, and it requires a lot of manual maintenance for people to sit and try and poke and try and get working in a kind of okay way. So that's like step one. That's like your operational reality for what a service might look like to the outside. Step two is, what if there is some kind of problem across all of this infrastructure? And what I mean is, the kind of problem that maybe your existing analytics don't pick up because you've got such a large combination of edges and users and paths that they're traversing that the 1% hit maybe isn't noticeable in terms of performance stats or traffic stats on a particular edge, that you don't see it when it happens. And your alerting mechanism becomes angry people on the internet, right? And they're telling you that your site sucks in a language that you don't understand, right? With apologies to anybody who's Finnish. I can't read Finnish, but But I have had this situation happen. And this kind of thing does happen, right? Lots of things go wrong in the network. You get a lot of congestion in the network. You get peering disagreements. You get people unwilling to pay each other for more bandwidth, despite the fact that they are overloaded. You get malicious intent, although I'm not going to touch that on this talk. You get hijacks. Fun fact, the big YouTube Pakistan accident is about 10 years old at this point, when Pakistan tried to block YouTube and accidentally blocked YouTube for the entire internet. And the reason that they were trying to block YouTube was because Geert Wilders, a Dutch politician, had posted an anti-Islam video on YouTube. So we have a contextual loop back into BGP hijacking, which I'm not talking about today. But ultimately, you have a kind of an open problem, which is you have your set of services that you're exposing to the world, and you have a set of users that are out there in the wild, in any network possible. And unless you do particular types of measurement, it can be difficult to understand and model where your users are coming from and why they're arriving on the edges that they are. Again, that's the baseline. That's your step one. Your step two from there is, if there is a problem, if you do have grouchy users on the internet, can you actually drill down and isolate what that problem is so that you can try and do something smart about that? The key point with a lot of this stuff is that you need vantage points to understand what's happening beyond your border, beyond your point of control. So, sidebar. How many people are familiar with the RIPE Atlas project? That's a good number of hands. How many of you are hosting a probe? Still a good number of hands. Scheduled measurements? Smaller number of hands. Used other people's measurements that you're not running? Oh, that's a completely different set. That's great. So the RIPE Atlas project is a globally distributed network of measurement probes of around about 10,000, 10,500, mostly small devices that volunteers host out of the goodness of their hearts. We don't pay them to do this. Generally, they just want to make the internet better and nicer in some way. So these wind up being hosted in residential networks, in schools, in offices, in data centers, in ISPs, in IXPs, in corporate networks, and wherever else. And the RIPE NCC service region is more or less where that large cluster is. Like that's where our most active users are. And of course, we are based in Amsterdam, so we hand out a lot of this stuff pretty locally. So we're very well covered across, for example, residential networks in Western and Central Europe. But we have a lot of probes all over the world, and we have a lot in particular in North America, the sort of people who turn up at IETFs and those kind of meetings. And so what we have with this platform is a lot of visibility in a lot of networks that your users are sitting in. What these probes allow you to do is run things like pings and trace routes and resolve names using the DNS and do NTP queries, and in a very limited set of situations will let you do HTTP queries. And it will let you do all of that over IPv4 and IPv6, so you get visibility into both of the networks. And the way that it works is it's kind of tit for tat. Like, you need to spend credits on the platform to do measurements, and you gain credits by hosting a probe that other people can run measurements from. So we're very volunteer-driven. We don't take money for this kind of service. In fact, it's very difficult for you to pay us to engage in this. And once you have credits, you can instruct the platform to run measurements. You can say, I want to ping or I want to trace route towards that particular target from some subset of the probes, and that can be, I don't know, give me 100 probes globally distributed, or give me 10 in the Netherlands, or give me 300 in the US, or any subset that you're interested in. Or give me like 5 in that ISP over there. And the platform will go and instruct the probes to do that, and once they are done, or even when they're running, you can then go and collect those results as a JSON blob, and you can then try and analyze that data or plug that data into other things. So back to the problems, which are How do you understand where your users are arriving on your edge? And once you understand that, how can you actually isolate a particular problem? Right Atlas starts to solve some of this. Obviously, you can build out a lot of this stuff yourself. Like I could go to Linode and spin up a few machines and run some trace routes. But maybe that's going to be different from the user that's grouching inside a particular domestic ISP. And what is valuable when trying to debug a particular thing is being able to understand what that ISP is doing to things like DNS, or where the packets are actually being routed to my edge from that ISP. So very briefly, I'm going to touch on a couple of the protocols that do a lot of the heavy lifting here. DNS, I'm not even going to ask you how many of you hate DNS. DNS is heavily distributed by design. It relies on a lot of caching. And some ISPs really, really like messing around with your DNS records. Some ISPs really, really like dampening down your quad A responses, your quad A answers, so you don't get V6 if they've done something bad. Some nation states love messing around with DNS for reasons that are up to them. Users love messing around with DNS by deviating from their ISP's resolver and moving over to a public DNS service, such as Google or Quad9 or Cloudflare or any of the other ones that are out there. But what is valuable if you're trying to understand where traffic is coming from and going to is understanding what's actually being resolved. Like if you've pushed a DNS change recently, you would kind of expect it to have been cycled out before the cache limit. But is that actually true? Like if users are grouching like 2 hours after you've made a change, is it actually that that ISP is holding on to the wrong results and issuing the wrong results for too long? These kind of weird things happen. The other side is if you get users grouching in a particular network, then the DNS-based, if you're using any kind of DNS load balancing, then being able to actually resolve the name that you're interested in from inside that network will help you understand whether their resolver is wrong or whether you, as the authoritative, are handing back the wrong IP address. It tells you also which edge you're sending your traffic to. So yeah, querying the DNS is interesting and it reveals a lot of stuff, and it can be a useful, really useful bootstrap for what's actually happening if you're trying to debug a thing. It can also be a really useful thing for monitoring on a regular basis to ensure that things are being balanced correctly, traffic should be going to the correct places. The other protocol that I want to hit on is traceroute. Traceroute is the workhorse of network measurement still. It's kind of an interesting side note in history that the only real measurement protocol that we have is ICMP, and that's leveraged heavily in ping and traceroute. And we've never really gotten better at it. These are the basic tools that people have been using for decades, and here we are in 2018. I have the word traceroute on the screen. But traceroute is really useful because packet forwarding is all essentially based on local decisions. And once you're out there, once you're in the network, you lose a lot of control over where your packets are actually going to go, where they're going to be routed, which networks they're going to pass over. Routing is essentially asymmetric. It's often symmetric, it's often asymmetric. You can't really guarantee it. You get a lot of control over your side of the equation, but not the other side. And it can be really difficult to debug what's happening in terms of packet forwarding unless you can actually get a packet trace to see where traffic is being routed. You can look at BGP dump all that you like, and unless you've got very specific vantage points, you will not be able to figure out where your traffic is going, probably. IP anycast. I'm saying IP anycast to multiple sites makes this especially tricky. I'm being relatively polite. But traceroute is really interesting, and routing is really interesting because it doesn't always go the way that you would expect it to. This is just one of the really cool plots that one of our colleagues puts together. Like, tilt your head, and you can see that the world is there. Australia is over here. It's a bit of a weird projection. But this cluster on the left here is a bunch of probes that are running trace routes to the nodes Dhaka in Pakistan. And some of those go direct through Russia or Asia, and a whole bunch of those actually go over the Atlantic through the US and pop out the other side to the Pacific and up through Singapore. That's an unintuitive path. And without actually doing the measurement to understand that, you wouldn't necessarily know that that was the case. Routing is strange, and in fairness, a lot of routing is very US-centric. We do tend to default traffic back into America. So once you have network paths, and once you have traceroute running, and once you have sufficient traceroute running, you have an understanding of which networks your user traffic is passing through. And sufficient traceroutes will tell you whether there is congestion or loss on any of those paths at particular times of day. Loss can be diurnal. And it will, if you're doing a TCP traceroute, so you send a TCP packet with the SYN flag set, and you expect something to eventually pick up once you've gone sufficient hops through the network, it will tell you whether things are consistently accepting that connection or not. It might tell you if you have an intermittent fault where something on the other end, the load balancer on the other end occasionally resets a connection. And ultimately, the win here is once you have many vantage points, you have the ability to understand in aggregate where some of your traffic is going and whether you have an intermittent fault along some subset of your paths. And then you can potentially route away from a problematic path, sometimes. So this is all of the networking stuff, and I like networks and I like measurements. Monitoring is kind of like the next step along. So you can model a lot of stuff once you have sufficient vantage points, and some other people out there do this. We at the NCC run the KRoute route DNS service, and we use the Atlas platform to understand where our traffic is being routed. That's not strictly a time-critical service. Like, we're not talking about shaving 100 milliseconds off of a request in the same way that maybe a CDN cares about performance, but it's something that we pay attention to try and optimize where our traffic is going and what it's doing. The Edgecast folks have spoken a bunch of times about how they are using the Atlas platform to do essentially the same thing, where they advertise a block of dummy addresses that don't attract any traffic, and if they push a configuration change, they measure Atlas against the dummy prefix to give them some confidence that if they make the same change on their production addresses, that their traffic isn't going to go all to the wrong place. And this is an iterative thing that they do every time they push a change. So where we sit as a RIPE NCC is that we, to a very large extent, we expose data. And because we expose data, people are then free to build these kind of tools on top of it. And some of the simplest stuff is that folks have been able to write hooks for things like Nagios and Asinga, but also Prometheus and other systems. And usually these are about as scratchy as you might expect something that somebody throws up on GitHub. But you can take some of this data and you can funnel it into your existing system. We have no desire to give you another monitoring platform that you want to have to look at, but we want to give you the data that you can potentially use to understand what's going on. And we do expose this data a bunch of different ways. We actually have reasonably well-documented APIs, but the primary couple things that are probably interesting is for any measurement that is conducted on the Atlas platform, you can get that data in near real time out of our streaming API. For pings in particular, we offer something like status checks that give you a true or false kind of flag on whether you're seeing a particular level of packet loss to a particular destination. And if you want to, you can pull down all of the data that we've collected for a particular measurement via the results API. And then we try and build some tooling on top of that. So the IP map service, the screenshot with the weird traceroute, for example, comes right out of the IP map service that we have. Tracemon attempts to take traceroutes and visualize at an abstract level the network paths that your traceroutes are passing through. And we have other services like DNSMon for doing DNS monitoring, of course. And the fun part, and some people maybe aren't so cool with this part, The fun part is that most of this data is public. Like around about 95% of the data collected on the platform is public data. And it's very easy to get access to that data as it's coming in. So Cousteau is a Python library that we maintain at the NCC. It's on GitHub. You can go and you can do pip install, write mumble Cousteau. And within a few lines, you can connect to the streaming API and start pulling down data. And this one that I have here on the screen simply says, give me all of the pings that are hitting that particular prefix, which happens to be one of Google's data centers just because it was an easy one to pick. And you can get the measurement data that people are collecting on the platform right now and pull that down just for funsies. Like it's there, and we want people to take it and use it. We, as a not-for-profit, rely on community support and feedback. If you're interested in some of this stuff, please talk to us, please build stuff. When you've built stuff, please tell us about the stuff that you've built. Get in touch, get involved, host a probe, sponsor us if you like, that would be cool. And otherwise, that's basically me for now. If you have any questions or comments on any of this or anything else, you can ask me right now. You can ask me tonight when you've put a couple of beers into me. And we have a couple of other folks from the NCC who are in here, so I'm going to name check them right now. And if you find somebody else from the NCC, they'll also gladly answer your questions. But that's everything for me. Thank you.
Do we have any questions?
Yes.
Do you have any other pointers to what to do with it in your plans?
So the question, as I understand it, is that oftentimes you can do this measurement and you can do this monitoring to find that there are problems out there, but you have no control over what the problem is. Yeah, that's definitely a thing. The internet has many stakeholders and many networks, again, that your traffic passes through. That's valid. The key is that at least having the information can allow you to determine whether you yourself can make a decision. So if you spot that there is packet loss on a particular path, you can then consider rejecting the route that would send traffic back through that path and route your traffic somewhere else. Like this is the kind of thing that if you have, and to do that, you need to have a good network ops type of set of people inside your own organization who are willing to also engage with that. Like if you don't have that relationship with your own ops people, then you could be hosed on all counts, unfortunately. But yeah, you're right. There are lots of cases out there where you can identify where the error is. You're like, well, it's not the user's ISP and it's not our upstream, so we can't really complain to anybody. That's a kind of a sad story. The tough part then is trying to find somebody who can actually answer, trying to find a human who can actually answer a question and try and get the concern inbound. A lot of the internet is based on who knows who.
Any more questions? We have time for one more. By the call.
Sorry,
what was the question?
I'm sorry. Has anybody done something really cool with this data and put it on the internet? A lot of people do stuff. There are a lot of this measurement stuff comes out of the R&D department, and so we're engaged a lot with researchers, and a lot of researchers use this stuff to understand what the internet is doing and how the internet is evolving. So there are lots of academic papers out there which may or may not be what you're looking for, but we do try and use the data to understand who is connected to who, and we do try and build some prototypes, and I can probably try and pull some of those out for you. We sometimes do a really bad job at surfacing this stuff, sadly, but we should try and do better, right? The BGP, yeah, so the BGP Mon Nyan cat was a very intricate way of advertising and de-advertising BGP prefixes to ultimately wind up with a Nyan cat displayed on the particular visualization. It took a lot of effort. It wasn't me.
Okay. Thank you, Stephen.
No worries. Thank you.